The server is running. Logs look clean. The process is alive. And yet your browser stares back with nothing. Connection refused. That is the strange first lesson of Docker containers. They are sealed rooms by design. Useful work can be happening inside, and the outside world has no doorway in. Tonight, we follow two related mysteries: how you open a careful door from the host into a container, and how you build a private neighborhood so containers can find each other by name, without giving up the isolation that made them safe in the first place. Picture a shipping container at a port. Inside it, everything is tidy and self-contained. Outside, cranes and trucks move freely. Without a deliberate ramp, nothing crosses the steel wall. Docker containers work the same way for processes and networks. Isolation is the feature, not the bug. But isolation has a cost. An application may be healthy and still unreachable because its internal network is not connected to your machine's network. The missing piece is Nginx running? The missing piece is the doorway. So where does the classic web server actually listen? Inside the container, Nginx expects traffic on port 80, the familiar HTTP port. That is an address on the container's private network stack, not on your laptop. You can pull the official image with Docker pull Nginx. You can even start it. But until you publish a mapping, your browser on the host has no path to that internal 80. The container is a sealed room with a phone jack on the inside wall, and nobody has run a cable to the hallway yet. Docker's answer is the publish flag, written as -p or the longer form publish. The shape you must remember is host:container. Left side is the door on your machine. Right side is the socket inside the room. So -p8080:80 means when something knocks on host port 8080, forward that traffic into the container's port 80. Protocol defaults to TCP. You can specify UDP when you need it. You can even pin a host IP if you only want the door open on one interface. The mapping is deliberate. Nothing is opened by accident. Here is the command that finally hangs the cable. Docker run -p8080:80, name the container web host, run it detached with -d, and use the Nginx image. Detached only means the process runs in the background. It does not mean the network is open. The publish flag does that work. After it starts, Docker is holding a narrow bridge, host 8080 to container 80. One doorway, one service, no mystery IPs required on your part. Just the port pair you chose. Now open a browser on the host and visit localhost on port 8080. The famous Nginx welcome page appears. That quiet success is the whole point of publishing. The process never moved to your host. Nginx is still living inside its sealed room. You simply gave the outside world a single, controlled entrance. If the page fails, the first questions are simple. Is the container still running? And did you publish the ports you think you did? We will return to those checks. For now, lock in the feeling. Alive inside is not the same as reachable outside. There is a trap waiting for every beginner, and the source is blunt about it. A Docker file can declare expose 3000. Docker inspect can show exposed ports on an image. That looks like an open door. It is not. Expose is documentation, a note that says, this service intends to listen here. It does not publish anything to the host. Running Docker run nginx with no -p leaves you with a living container and no external doorway. Publication is always an explicit choice at runtime, or through carefully designed compose and orchestration later. Documentation is not connectivity. The same doorway story shows up when the app is yours, not Nginx's. Imagine a simple React front end you create locally. You write a Docker file that builds the app and ends with a process listening on port 3000. Inside that file, expose 3000 records the intention. It tells teammates and tools where the app expects traffic. It still does not punch a hole through to your laptop. Think of expose as a label on the inside phone jack. The cable to the hallway is still a separate act. Build the image with docker build-t basic-react-app and a dot for the current directory. Then run it with docker run-p3000:3000 detached using that image name. Notice both sides of the colon are 3000 this time. That is allowed. Host and container ports do not have to differ. They only have to be a conscious mapping. Visit localhost 3000 and the React app should answer. Two different stacks. Nginx on 80, React on 3000, same pattern. Choose the host door, name the inner socket, publish the pair. When the browser stays blank, you need a small toolkit, not guesswork. Docker PS shows whether the container is up and which ports are published. Docker port prints the host to container mappings in plain language. Formatted Docker inspect can reveal exposed ports and network settings without drowning you in JSON. Docker image inspect does the same for the image itself. Together, they answer two different questions. Is the process alive? And where is the doorway? Those are not the same question, and mixing them up wastes hours. There is one more publish style worth knowing. P tells Docker to publish every exposed port to a random high-numbered port on the host. Handy for quick experiments, harder to remember for bookmarks and demos. Most of the time, you will prefer lowercase "p" with an explicit host port, so teammates always know which door to knock on. Either way, the principle holds. Exposure documents intent, publication creates the path. Opening a door to the host solves half the story. The other half begins when two containers must talk to each other. By default, they are strangers. Each has its own network namespace. Hard-coding IP addresses is fragile because container IPs can change when things restart. What you want is a shared neighborhood with name-based discovery, a place where Web Server 1 can simply ask for Web Server 2 by name, the way neighbors use street addresses instead of GPS coordinates that drift every morning. Start by seeing what networks already exist. Sudo docker network ls lists them. Docker ships with defaults, including a default bridge. For real applications, the source recommends something better, a user-defined bridge network. Create one with docker network create my-app-network. Think of it as pouring a private street between buildings you control. On that street, Docker can offer automatic service discovery and clearer isolation than tossing every container onto the default bridge and hoping for the best. At first, the new network is empty, a street with no houses. Then you launch two Nginx containers onto it. Docker run detached, name web-server-1, attach network my-app-network, image Nginx, repeat for web-server-2. The double dash network flag is the moment each container gets an address on your private street. They are no longer isolated strangers. They share a communication space while still remaining isolated from networks you did not join. Curiosity next. Docker network inspect my app network returns a detailed picture, including a containers section. There you see who is attached and which IP addresses Docker assigned. This is the map of the neighborhood, names, endpoints, and the quiet plumbing that makes name resolution possible. You do not have to memorize those IPs. The inspect output is there when you need evidence, when something fails and you must prove membership, not just assume it. Here is the payoff. From inside the first container, run docker exec interactive on web-server-1 and curl http://web-server-2. No IP address, just the container name as a host name. The request succeeds because the user-defined network provides DNS-style discovery among its members. That is the feature you do not get as cleanly on the default bridge. 2 sealed rooms, 1 shared hallway, nameplates on the doors. Modular services can finally compose without brittle address books. Life is not always greenfield. Sometimes a container is already running when you realize it needs to join the neighborhood. Docker network connect my app network. Then the container name or ID attaches it without a rebuild. A single container can even join multiple networks, like a building with entrances on 2 different streets. Connectivity becomes something you shape over time, not a one-shot decision at birth. What you can join, you can leave. Docker network disconnect my-app-network web-server1 removes that container from the street. Afterward, name-based calls that depended on membership fail, which is exactly the point. Isolation returns by design. Networks are not a permanent fuse, they are a controllable boundary. In production thinking, that boundary is as important as the connection itself. Blast radius stays small when leaving is as intentional as joining. Step back. Port publishing and user-defined networks are two chapters of one discipline. Publishing is the doorway between host and container. Host:container, explicit and narrow. Networks are the streets between containers, names instead of fragile IPs, membership you can connect and disconnect. Expose writes a label, -p hangs a cable, Docker network create lays a private road. None of these abandon isolation, they make isolation useful. So the sealed room was never a dead end. It was a demand for deliberate architecture. You learned to open a single host door to Nginx and to a React app, to debug mappings when the browser stays quiet, and to gather services onto my-app-network so they find each other by name. The opening stakes are resolved, reachability without chaos. The question the field keeps chasing is larger. As systems grow, many services, many environments, zero trust edges, which doors should exist at all? Who may walk them? And how do we keep controlled communication from quietly becoming an open city? That is the next street over. For tonight, you have the keys to the first two locks.